Academy sponsored on Atal Academy sponsored online 1 week faculty development program on artificial intelligence and IoT in Industry 5.0, shaping the future of smarter industries. As we all know, AI and IoT are the two of the most exciting technologies that are transforming the way we live, work, and interact with each other. Our FDP today has invited two eminent speakers to share their insights and experiences with us. Our first speaker is Dr. S. Brinda, a national awardee for Best Teacher. This prestigious award honors outstanding teachers who exemplify excellence in education, inspire their students, and contribute significantly to student communities. Dr. S. Brinda received this prestigious award from our Honorable President, Srimati Draupadi Murmu in 2023 on Teachers' Day at New Delhi. Ma'am, I am privileged to introduce our beloved HOD, coordinator of this FDP and host speaker of today, Dr. S. Brinda. She has more than 24 years of teaching and research experience at PSG Polytechnic College, Coimbatore, Tamil Nadu. Dr. S. Brinda did her schooling in St. Joseph's Matriculation Higher Secondary School at Tirupur and finished her bachelor's in engineering in Tripoli in the year 1999 at Maharaja College of Engineering. Dr. S. Brinda joined PSG Polytechnic College in the Department of Computer Networking as lecturer in the year 2000. She has completed her master's in applied electronics at PSG College of Technology in the year 2016, 2006, and completed her doctorate in information and communication engineering in the year 2015 from Anna University, Chennai. Dr. S. Brinda is also the coordinator of autonomous functioning at PSG Polytechnic College and has been instrumental in implementing outcome-based education, setting up industry-based laboratories, introducing new electives, signing MOUs with industries, etc. She has published many technical research papers and curriculum design-related papers and won Best Paper Awards in conferences. She has also won the Special Women Achiever Award from PSG Trust. Dr. S. Brinda has also received the Best Student Project Award titled AICTE Chhatra Vishwakarma Award in the year 2018. She is a life member of ISTA and IE. Now, I now request Dr. S. Brinda to deliver her lecture on IoT architecture. Thank you.
Yeah, good evening, everyone, and thank you for the warm introduction, Priya. And yes, today we are into IoT. And when we were planning with a small introduction, let me start this. When we were planning for this FDP, we thought of including new technologies, and definitely we understand that AI and IoT are together the cornerstones of the present Industry 5.0 architecture. So we thought we have to include both the digital twins, AI and IoT, in our proposal. And as such, we included, and the course is now going on. And many of the faculty members or even many of the people in the industry would have experienced the sudden surge of the words AI and IoT in all the places, like wherever we are doing any work, maybe it may be the industry or maybe our own teaching profession or even in the computer industry or any construction industry or smart cities, many projects, wherever new things are happening, they are all involving IoT and they're all involving AI. So the main key thing is to make devices intelligent, and as well as the devices should be able to communicate with the internet, and the devices should be able to make decisions rather than communicating what is happening to a human being. The devices should be able to make decisions by themselves and implement those decisions, and only when there is a need to tell to a human being, only then the human being will be intimated. The whole idea behind this Industry 5.0, right from we're all moving from Industry 1, 2, 3, 4, and 5, the whole idea behind this is human centric. They say it is human centric, but we also hear about robots, that is the robots, collaborative robots, which are all working together with the human beings. So what do we mean, whether this AI, IoT, all these technologies, whether they are all intended to replace human beings or they are facilitating human beings? So when we are on the dig for knowledge, definitely we get this question. So by looking at the projects that are coming up and looking at the things that are happening, we can understand that this is a very crucial topic, and this needs discussion from all the experts all over the world. And as far as my understanding, I would like to emphasize that this AI, IoT technologies, or all the technologies, blockchain, security technologies, or even fog computing, or whatever new word that comes here, everything is aimed at uh, reducing the fatigue or reducing the difficulties for the human being, and it is a facilitating a human being. Okay, so it acts as a human facilitator. So wherever the tasks are very dangerous, wherever the tasks are very complicated, that could be given to a machine, that could be given to a cobot that can do it, and human beings can just enjoy the facilities, and they can definitely look into other alternative options. So definitely this AI, IoT technologies in medicine are all predicting diseases, just like doctors, how it is arriving at conclusions. And such technologies are nearly definitely a welcome one, so that we get the intelligence of so many computers together, put together, and we make a decision. So we are getting so many brains to work for us. That is the idea behind that. So definitely, as such, all technologies have to be used for the betterment of the society. So here we are to learn about the IoT architecture. Yesterday itself, we had an introduction with Industry 5.0 and what are all the various AR, VR options. And there are many good sessions that are also scheduled on the line, where you will be looking at how to create robots, or many what are all the new devices that are available from the industry experts. And today my focus is on to give an introduction to the current IoT architecture with respect to the industry 5.0, since things have changed, whether anything is changed in the IoT architecture, any new protocols have come. So that is my perspective. So before going into that, we all know that IoT stands for Internet of Things. It refers to the network of interconnected devices that communicate and exchange data to perform tasks and improve efficiency. So anything that is connected to the internet, that comes under Internet of Things. We have many things there: artificial intelligence enabled Internet of Things, Internet of robotic things. Robots are connected together. So IoT, many new concepts are joined with IoT. So anything that gets connected to the internet, we call it as an Internet of Thing. Earlier it was Internet of computers, but now anything can be connected. That is IoT. IoT, when it has been evolved from basic machine-to-machine communication model to a complex ecosystem, growing rapidly due to the advancements in wireless technology and data analytics. Yes, initially when we coined the term IoT earlier days, whenever a smart bread toaster, for example, would be an example of an IoT. Earlier days, 2003 or 2010, the time period was like that. Any small machine which can do its things automatically, or it can sense and tell us what it is doing, like temperature sensor. It is having one sensor and giving us the data. We call it as a IoT device. But later on, the evolution has moved. It has grown in such a large way that many devices are connected to the internet, and due to the seamless connectivity provided by the wireless technology, the storage provided by the cloud and the fog system, and the security provided by blockchain. So with the advantage of so many things and the applications that are taking place, maybe in the smart city transportation system, or in the supply chain management system, or in the hospitality industry, or in the agriculture industry. So then the IoT, the fruits of IoT have been witnessed, and it has grown to such a large extent. So the key components of an IoT system are sensors and actuators, networks and connectivity, data storage, and processing. So three things. So yes, first I need some sensors and actuators. That is, these are the physical layer of the IoT, wherein we need some sensors to collect data from the environment, while actuators will execute the actions based on this data, forming a fundamental layer of IoT systems. And networks and connectivity, we definitely need a network through to transfer the data from the devices, from the sensors to the computing device, and then the decision has to be implemented to the performing device. So we need a network for that. So all wireless network protocols like even Wi-Fi, Bluetooth, Zigbee, or all the protocols. So network, there are a set of IoT protocols which can be used for connecting IoT devices. So that is all provided by the networking. And then data storage and processing. Yes, the data collected by the IoT devices has to be stored and it has to be calculated. And based on the computation, some actions have to be done. So the key difference between the cloud and fog computing comes is, if the data storage is done in a cloud, that is, it is done in an internet, then the processing, everything is done in a distant place, that you call it as a cloud, that is, it is in an internet. Whereas if you have a local source to process the data and storage, a nearby cloud, that is, we are zoning it, then we call it as a fog computing model. So we're moving on to the main crux of this IoT architecture layers. So when we talk about the layers, yes, why do we want all these layers? Architecture is itself, whenever we talk of architecture, we always say, where can we see IoT architecture? It is such a theoretical point. Can I see any difference in that? Uh, how to visualize all these layers? But the thing is, uh, you could have thinking of a cake with a multiple layers. It is a 7-layer cake, 10-layer cake, then it is very costly. But if a cake is having only 2 or 3 layers, it is less costly. So when the number of layers increase, we all get an option to add our own customization to that particular layer. Okay, so IoT has started with a 3-layer model. Later on, it is now at present in a 7-layer model. So number of layers has increased, meaning that in each layer we get some flexibility, we get some convenience, we can add our own customization in each layer. So in the 3-layer model, we had this perception layer, network layer, and middleware layer. I've also presented you all the architecture, 3-layer, 4-layer, 5-layer, and 7-layer architecture all together in a diagram. So in this, the primitive IoT architecture comprises of 3 layers: perception layer, network layer, and application layer. So we'll just finish that and come back to this. So perception layer is to perceive, meaning that I have to feel something, I have to get something. So definitely the meaning says that it is the sensors. So all the sensors come under this layer. So we have different sensors like temperature sensor, infrared sensor, motion detector, light sensor, or whatever sensors. Okay, moisture sensor, many sensors are there. All these sensors and the data they collected, that comes under this perception layer. Okay, so this layer is equivalent to, if we think of the OSI layer in the networking, this layer is equivalent to the physical layer, wherein we can see the devices really. So sensors can be seen, we can have different types of sensors, and definitely how the data is to be collected in a sensor and in how we are going to present it. Okay, so that also comes under this layer. And then comes the network layer, wherein we think of the communication protocols and security considerations. So initially we had protocols like MQTT, QAP, HTTP. All these protocols facilitate data exchange between IoT devices and networks, ensuring seamless communication. So whenever think of so many options, why so many options? What is the need for so many options? It is all dependent upon the application and say for example your Alexa is also using all these protocols and all these AI thing. So your Alexa device collects all the data and has a small computing power within it, so that it uses a fog computing model also, and it also uses uh, by Bluetooth protocol, wherein you can compute nearby, only then it can make decisions fastly. So like that, based on the application, like if at all Alexa is not able to use Bluetooth and if it is using Wi-Fi, then it will be in a different range of communication. The speed and everything will vary. But if it is using Bluetooth, and accordingly the distance varies and all the things are varying. So the selection of the protocol, how it is using, uh, what is the application, it all decides the speed, the efficiency of that particular application. And then comes the middleware layer. It is also called as the application layer, wherein we develop applications and we host them uh, for different applications. Okay, what is the application? Like for what we are developing. Okay, so this has three parts wherein it focuses on organizing, storing, and processing data collected from IoT devices, or it also enables them to work together. It also allows hosting IoT application, including cloud services, server management, and ensures scalability to handle large data volumes. Yes, initially when an IoT device is created, we'll be in a lower layer or lower model, wherein only less number of devices will be there. But once it is in the higher end, when it is scaling up, then definitely we have to give it some convenience there. So that part is taken care of in this application layer. So this is a generic three-layer model, which is always available in any book. If we see, this three-layer model will be available. But now IoT has moved forward, 4-layer, 5-layer, and then the 7-layer architecture has come. So what are all the layers that has been added? So in the 4-layer architecture, we have the edge computing added, and then we have internet gateways added, and then we have cloud or data center model is also there. So all these options are available in the 4-layer architecture. In the 5-layer architecture, we have perception layer, transport layer, processing layer, application layer, and business layer. So what do we mean by a business layer is the business layer automatically draws graphs, takes insights, collects the data for a particular period, and presents the data, makes decisions, and presents the decisions to the stakeholders of the business. So that's why it is called as the business layer. Okay. It is sitting on the top and it is making top of application layer. That is, it is next to the application layer. So it collects the data, it makes graphs, it takes decisions, and those decisions are in turn given to the stakeholders and for their knowledge, and then it implements decisions in a business layer. So that's why it is called as the business layer. 4-layer model also, we can say there is application layer, support layer, network layer, and perception layer. So the perception layer, what new thing has been added in the perception layer in the 4-layer architecture is we have been added encryption and key agreement, sensor data protection has been added. Whereas in the network layer, we have gateways, internet gateways are available, identity authentication, encryption mechanism has been added in the internet gateway. And we also have support layer we have, wherein we've added edge computing um, is provided, and also antivirus protection is also given. And in the application layer, we have authentication, key agreement, and privacy protection. So all these options are available in the 4-layer model. So whenever we are moving up in the model, definitely the attacks in those layers is also increasing. So what are all the security threats if you look at in this 4-layer model is we have the denial of service attack or even the insider attack. Say for example, a scammer who needs to get the login credentials of an existing IoT system user can get it, and they can upload malicious code to the system to run it or get sensitive information. Okay, so that is called as an insider attack. Insider attack, he gets the login and credentials of an existing IoT system user and they upload malicious code. Usually, whenever a big attack is happening, usually this insider attack will definitely be there, because without getting the login credentials, of a secured user, it is not possible to create such a big attack. So that is also there. And next comes the 5-layer IoT architecture, wherein I told you that a new layer called business layer is added. Uh, business layer, as I told you, it provides, it makes decisions and it informs to the stakeholders. So that is the main idea of this business layer. Whereas if we come to the final 7-layer architecture, you have perception layer, connectivity layer, edge computing layer, processing layer, application layer, business layer, and the very important thing is the security layer. So because IoT devices are also prone to attacks, many types of attacks are happening on IoT devices, IoT models. So to name a few, you have man in the middle attacks, you have insider attack, you have malwares that are spreading, um, sometimes exhaustion. Okay, because IoT devices are facing this type of attacks, that is the exhaustion attack. That means exhaustion is not an attack, exhaustion is a threat. That is the IoT devices, the attack, it aims to drain the battery of the device. 100% of a computer's processing power is taken off so that it won't be able to do any tasks. Okay, even in our own mobile phones we face this problem. Sometimes over usage, over a usage of 1 or 2 years, we see that the battery gets drained faster. Even after recharging, the power does not withstand. So that is one type of thing that is happening. So in this IoT devices, this type of attack is triggered. Okay, it is not happening naturally. We trigger an attack wherein the battery's 100% power is taken off and the device is exhausted. So that is called as exhaustion. Also, since tons of data are being gathered in this IoT devices, so there is a chance that Trojans or computer viruses will get into a system. So in addition, they may provide unauthorized access to data and databases for scammers. So since more data transmission is involved, because earlier days we used to tell if there is a log file for intrusion detection log file, you'll be seeing lot of log file messages. It will be very lengthy message, very lengthy file with all types of entries. So for example, if you have a temperature sensor and if you get its data every 5 minutes, then definitely every 5 minutes or every single minute, if you're getting the data will grow in size. So the data is getting bigger, the definitely then the chances of intruding it, the chances of changing the data, or the chances of during the data transfer any malware applications being inserted into the data and changing the data. So all those chances are happening. So security layer is added in the 7-layer architecture to take care of all the different types of threats and attacks that are possible in IoT, and how to do it in a better way. Say for example, in the business layer, I told you that some decisions will be taken by the IoT device. Say for example, you can see that if at all a device needs to be maintained, predictive maintenance. Okay, that is one, preventive maintenance we say, but here it is predictive maintenance. Predictions are happening everywhere. We do prediction. AI is used. This term prediction is getting very common nowadays. So we have prediction for stock market. We have prediction for cricket or everything. Wherever we want, based on a data, we are able to predict the next set of data. So that is the predictive concept. So predictive maintenance, how it is done is in an industry, if there are many machines are there, we can see, we can use by using all the sensors, we can get the data from the machine and we can analyze it, and we can see that the oil levels are less. So definitely we can remove this device and we can put another transformer there. So we can take up a backup transformer and put it there before the transformer even breaks up. We are able to find out that the transformer is going to break down. So we are predicting and we are changing the transformer and ensuring seamless performance. Okay. So by this way, the decision making is done. So that's all coming under the predictive maintenance part. So in the 7-layer architecture is the one that is presently being used in industry 5.0. What is the differences? Yes, we have perception layer here. We have network layer here. Instead of network layer, I have divided it into 3 layers like connectivity, edge computing, processing. So all these things were happening together. Now it has been given in a separate way. So what protocols are used for connectivity? There are many options. You can select one. So you can either use edge computing or fog computing. So you can select one. There comes the edge computing layer. And processing layer, how we are going to process data. So that also is happening in a different context. We have application layer. On top of it, we have business layer and security layer. So just like IoT has now become a 7-layer cake. You have so many layers, so many options, and in each option you can make a selection which is suitable for your model. So we're definitely going to look at all these things. Next, we're looking at the communication protocols. So we were initially looking at the layers. This is the layering, and then we are coming to the communication protocols. So many protocols are used in IoT. So we are just highlighting what are all the important protocols and what is their central idea. That is the main thing here. So protocols like MQTT, QoAP, we have data distribution, HTTP, Bluetooth and BLE, and even LoRaWAN, 6LO WPAN architecture, 6 LoRa WPAN architecture. So that is all these protocols we're going to analyze. So we'll start with one by one. The first one is the MQTT. It is a very fundamental protocol. Just a minute, the MQTT. It is message queuing telemetry transport protocol. It is a lightweight messaging protocol for small sensors and mobile devices optimized for high latency or unreliable networks. It is ideal for remote monitoring, real-time data streaming, and IoT applications due to its low bandwidth requirements and efficient message delivery mechanisms. This MQTT is being fundamentally used in IoT systems right from the beginning. It is a very common protocol. It uses the publish subscribe model, wherein it uses brokers, it uses mediators. Okay, so rather than the client server model, you have somebody called the mediator or the broker, wherein the sensor publishes the data to them, and then the brokers in turn give the data to the computing devices. They subscribe. Okay, for to whomever have subscribed to the broker, for them the data will be published. So that is the message queuing telemetry transport system. So here in this example, you can see temperature sensor which publishes the sensed temperature as 21 degrees centigrade to the broker. But the broker will publish the same data to whichever devices who have subscribed to it. So that is this publish subscribe model in the MQTT. We also have QoAP. This is also a latest protocol. It is another promising protocol in the future of IoT. It transfers documents in a way similar to HTTP, but however, QoAP's design fulfills the need of constrained nodes. The packets in QoAP are much smaller in size when you compare it with the HTTP TCP, and it also uses UDP. Does not use the conventional TCP protocol. It uses UDP protocol so that the small packets are exchanged in the connectionless datagram model. UDP is a user datagram protocol. I think you all know. TCP is a transmission control protocol, and TCP is a connection based one, whereas UDP is a connectionless one. So for fast delivery of small packets, which are called as datagrams, we use UDP usually. So this is a common thing that is available in the networking, that is taken in the IoT in the name of QoAP. Okay, so QoAP is a constrained application protocol. It is designed for simple electronics with low power and computational needs, making it suitable for our IoT devices with constrained resources. So like building automation, smart energy systems, and resource constrained environments where lightweight communication is critical. Say, for example, nowadays robots are available everywhere. Robots or cobots are available everywhere, even for construction site, even for painting, for plastering, for cementing, all these purposes. robots are readily available and they are being used. So when communication has to happen among such devices, the communication will be converted into very small datagrams and they are being transferred so that we get faster transfer of data. So you can see here this constrained application protocol co-app. Okay. So here it acts on the client server model. Clients can get, post, delete, and put the resources. That is, whenever you want to get the data, you can put the data, you can do that. We use tags like confirmable and non-confirmable for request and response messages. This is somewhat similar to how you talk in an FTP model, wherein some request is given and then a response is given. It assures, CoAP assures data security, and it assures that the data transfer takes place through UDP and not in TLS. So in this diagram, if you see, there are servers, there are clients, all the clients are communicating. Say, for example, one client is communicating using HTTP, that is one model. Whereas using this CoAP, many clients can communicate to the server because they're all exchanging small datagrams. So that is possible. Okay. So the clients can exchange small datagrams using the UDP protocol, and that is here called as the constrained application protocol. We also have even XMPP protocol, that is like extensible messaging and presence protocol. So that I've not included, but that is also a common protocol that is using XML language. It is like a middleware and it is message oriented. And we also have the next one is the data distribution service. It mainly revolves around data and it knows how to transfer data from one messaging point to another. In message-centric middleware, programmers write code for sending messages, whereas in data-centric middleware, programmers write code on how and where to share data values. So DDS ensures secure message transfer and data sharing. So here you can see the data writers are there and they all write on how to share the data values, how and where to share the data values. So that is the data distribution service protocol. It takes care of data. So we'll have a large amount of data with us. Being an IoT sensor, we'll definitely have a large amount of data. So what data is to be shared and when it is to be shared. So it is all taken care by this data distribution service. So if at all you want to get quick results, smart decisions, and much revenue, you can use this DDS. And we also have this HTTP, HTTPS is also available. Traditionally, sometimes we have large amounts of data has to be transferred, then we use HTTP or HTTPS. It is a standard way for communicating through web browsers, and we also have performance and security and all is good in HTTP and HTTPS is there. We also have secure encrypted communication in HTTPS. And then comes the Bluetooth and BLE, that is the low energy, Bluetooth for the low energy. So that means here the Bluetooth nowadays it can work in a low energy mode, so we can use it in a extended range. And we also have many applications nowadays. If you can see the Apple Watch, if you're going to something happens, that is if you're falling down due to some fainting or something like that, the Apple Watch senses it and it alerts to an ambulance nearby, and the ambulance immediately comes to your place, picks you up. So all these decisions the Apple Watch has taken by itself. So it is all possible because of this low energy Bluetooth protocol, because that only allows, okay, that only allows, it is it consumes less energy, and due to this less power consumption, it is possible to connect devices with small battery. So how it has been achieved is because of its the package size is very small, the data package is very small, and hence it is possible. So for such a small package, such small energy level is sufficient. Next comes the LoRaWAN. It is a type of long range communication. So for that, we use this LoRaWAN. It allows users to communicate long distances by consuming less power. If you can, even if you see in the, just you can go to an Amazon shopping website. If you just put on IoT devices, you can see lot of devices, home automation based IoT devices, wherein it allows you to switch on and off the lights, fans in the houses, or even AC remote controlling, AC control even using your cell phone. Or if you have some pet animals and if you want it to be monitored, you want monitoring, 24-hour monitoring of the pets, that is all done using IoT. Or even if you have any other monitoring, any other sensing of data, okay, gas leakage detection, even with respect to home automation or even with respect to industry, there are a lot of devices have come. So IoT devices, if you think of how in the real world, the networking world, we buy a router, we buy a firewall. So with respect to IoT, we have to buy long range router, a long range LoRaWAN device. That is what is required to make all these communication possible. So in the long range devices, there are many classes, class A, B, and C. Class A contains battery powered sensors. Class B contains both battery powered sensors and actuators. And finally, class C are main powered actuators, which are plugged into some form of power. So difference in operation is done on the basis of how these devices operate with and without power. Okay. So three types of devices, whether the devices can operate with battery or they have to be given direct power supply. So that makes the difference here. And there are other protocols also like Z-Wave, Zigbee, many other protocols which are available, which all can be used. And then comes this 6 low WPAN technology. It is a wireless technology that is a combination of something that ends with 6. Any guesses from the participants? That is, it is IPv6. Since we are connecting all the devices to the internet, then definitely the number of devices that are connected to the internet has grown up. So definitely IPv4, that is Internet Protocol version 4, the IP addresses has over. So definitely we have to go for more number of addresses are required. So we are going to use IP version 6. So only we call it as 6 starting with. It connects small devices with less processing capabilities to send information wirelessly over an IoT protocol. It ensures that small devices can connect to the IoT framework as well. It also uses the request response protocol. It takes its request from clients and passes it to users who give back a response. So in this architecture, you can see there is a gateway, there is a fully functioning device, and there are reduced functioning device, and there is an IP communication that is happening. There is a server, IP enabled device, laptops, computers are all communicating using this. So, and other than this, we also have many other new protocols that are coming up, which are all can be used for this IoT. So with respect to protocols, we have seen, I think, at least some 4 or 5 protocols like MQTT, CoAP, data distribution services, normal HTTP, HTTPS, and we also have Bluetooth low energy, and then the LoRaWAN model. This is the LoRaWAN model, and then the 6 LoRa WPAN architecture that is also there, which uses IPv6 and LoRa personal area network, that you call it as WPAN. So these are the protocols which we have been telling you, and all it nowadays this the network that is used is also 5G networks are being used, and even if you are using uh, protocols like wireless protocols or wireless protocols that are included in the IEEE 802.15 range, all supported by IoT devices, and all the protocols are available. Whichever you want, you can select. finally we come to the next thing, that is the data management and analysis. So whether we are going to have what type of data management is available. So we have cloud storage and we have edge computing models. We also have fog computing, that is also there. So which means that cloud storage, we are all by this time, we are all aware of what is fog or what is cloud. It involves scalable and cost-effective storage options, which is provided by AWS, Google Cloud, and Azure. So we are all using Gmail, or we are using all applications wherein we are putting all our Google photos, everything. We are putting our data in the cloud only, mostly. So large amount of data storage has been now moved to the cloud, whether in your mobile phone or in your laptop or in anywhere. It is all moved to the cloud, and we are all using it. Whereas edge computing, it refers to processing data closer to where it is generated to reduce latency and bandwidth usage, enhancing speed and security in data handling. Similarly here, fog computing, what is that new word? Fog computing. It stands for decentralized computing infrastructure, where the computing resources are placed between the cloud and the data source. So fog actually refers to a cloud's periphery or edge. Okay. So the end of, the edge of a cloud, I call it as fog computing. So whether fog is better or even cloud is better, yes, fog is definitely better. Edge is better, okay. In that we have the computing, okay, it is taking place at the device itself, okay. So, but whether which one is good, fog computing or edge computing, whether they are the same, no. Uh, Sometimes they are same in a way that both technologies leverage the computing capabilities to push intelligence down the network's architecture's local area network level. In that way, they are one and the same. That is, instead of making all the computations in the cloud, some of the computation is done in the source, near the source itself, where the data is collected. Near that itself, if you're able to make some computations and do some calculations, then that you call it as edge computing or fog computing. In a way, that is same only. But one of the significant differences between edge and fog computing is that in the data processing, in fog, data is compressed with the fog node, whereas edge computing processes the data on the device or sensor without being transferred to any other infrastructure. Okay. So edge computing on the edge, that is, the data is calculated on the sensor itself. That is, if you are going to take a temperature sensor and that itself you need some computing capability, you call it as edge computing. But whereas fog, the data is compressed and it is taken to a nearby node and then it is processed, so that the time, resources are all saved and proper data collection analysis are happening. So fog computing is in a way better when compared to edge computing. So both prevent the computation task from being carried out at the cloud, and thus it is saving time, resources, and money. So they always help businesses reduce their reliance on cloud-based platforms for data analysis, which leads to latency issues and reduces the time taken to make data-driven decisions. So initially, when we are given something for free, we all enjoy it. Yes, cloud storage, when it is given initially free, we are all able to enjoy it. But whereas when the amount of data gets more, the more the amount of data and the more computation is also happening in the cloud, definitely we have to pay for it. And nowadays, all businesses, when we speak to business people and when we speak to industries, the major cost happens with the cloud only, cloud storage, cloud security, cloud computing, and all those things. So the cost happens there. So in order to reduce that, we can make a little bit of computing, whichever is possible, near to the source and make decisions then and there. That is, for this, if we can consider the example of a traffic management system in a road. Say, for example, there is a traffic monitoring sensor is there, like a camera is there, it is monitoring the traffic. Whenever it is sensing an ambulance, okay, An ambulance is definitely having some different type of, either by means of sound or by means of some device attached to the ambulance. We are able to sense an ambulance. Okay, instead of telling that an ambulance has been sensed to a remote control center which is located far away from that place, that is, from the signal it is being communicating to the remote center, and from there the decision has to be made that immediately change the signal to green, and all the vehicles are allowed to move past. So instead of sending the data and then getting the answer, so that will take time definitely, though you are getting high speed, though you are getting 5G, 6G or anything you are getting, definitely that is to be avoided. However fast it is to be avoided. Okay, unnecessary transfer of data and computation in a distant place. Instead of that, if we have a computation there itself it has found out that an ambulance has come, immediately the decision has to be made that the signal has to be turned to green, and that computing and that decision making, if it is done in the same traffic light itself, in the same device where the sensor is available, where the cameras are available, where the, so in that place itself if the decision is made, then definitely the efficiency will increase, and that is where the human being who is in turn uh, deputed to do all these jobs is being collaboratively helped by this cobot. Now I can call this as a cobot because it is doing some task by itself, and it is using some if it is having some robotic technology to lift or do some of the gates or something like that, then I call it as a cobot. Okay, it is collaborating with a human being there and it is doing some work. Okay, so that way I can, it is humans have to now allow these devices to work. We have come to a phase where we are just like orchestrating. Okay, just like in a music orchestra, the orchestrator, what he does, he knows what instruments are there, how it can play, and we have to use it accordingly. Okay, so like we are in that age of industrial revolution wherein we have to orchestrate. This word was used by industry giants. I'm not using it, it is being used, the word orchestrate. That is, what they tell is we have to use AI, we have to use IoT, we have to use blockchain, or all these technologies are not required everywhere and for everything. So, IoT, the fundamental concept of IoT is to connect anything to anything, anywhere, anytime. That is IoT. Okay, but it is all not always necessary all these technologies should be enabled, so we have to enable which technology. Okay, so for this type of decision making I can use fog computing, wherein the decision is made there itself, that is, in that place I'm collecting the data from the sensor and I have some computational power there and I'm doing that, then I call it as fog computing. Or even at the time of collecting the data from the sensor itself, if I'm doing some calculation there in the sensor, then I call it as an edge computing. The edge devices are having some computational power, then I call it as edge computing. Whereas fog computing is just like it sits between the cloud and the edge. Okay, instead of going and taking everything to the cloud, I have a small fog wherein I can make some calculation and make some decisions there itself. So fog computing is definitely a blessing in that case. Okay, in all cases whenever we can use this fog computing, definitely the efficiency will improve. Both technologies save time and resources, but definitely we can, based on the application, we have to trigger, we have to use what technology I want. AR is there, augmented reality is there, virtual reality is there, many technologies are there. So whenever we are designing an application, we have to think of which technology is required for me. Okay, for this application, which technology is required, and for that what will be the technology enablers. So that is what we have to decide. Now we are in that stage. Okay, definitely we can see that earlier days we were having some AI is not a new word, isn't it? Artificial intelligence is a word that has been available in 1950 onwards. Yes, that word is available, but why it has gained popularity now? Any ideas? Yes, it is because of the computational power. Now we have the computation power. We can compute and give the answers in such a fast rate. We have got processors that are doing so much. That is, instead of CPU, we are having GPU. That is, graphical processing units are available. So because of that computing power only, we are able to make decisions such a faster rate. By analyzing so much data, we are able to make decisions. So because of that only, AI has gained popularity nowadays. Okay, earlier days this AI or machine learning was available, but in order to train a machine, it took large amount of time, and after training and after doing all these tasks, and it was able to do only a less amount of automatic tasks. Okay, but nowadays, because of this computational power and the computational power in each place, okay, it is not only at the end we are doing computation. We can compute only even in the at the place of sensing, at the place of actuators, or even at the niche layers. We found many layers are there. So in each layer I can add some computing capabilities added, then we can get remarkable results. So what are all the data processing techniques? So data processing techniques, we have real-time analytics, machine learning integration, predictive maintenance. So real-time analytics, that means it enables immediate processing and analysis of data as it is collected, allowing for timely insights and decision making, critical and fast-paced environments. So definitely we need real-time analytics, because we don't want to analyze old data. I just want to know what is the traffic pattern right now in my Google. If I'm opening my maps, any map application, I just want to know the traffic scenario at present in my path, and we want immediate decision. Immediate decision has to be made. I don't want any decision based on a regular pattern. Okay, that I don't want. Okay, so real-time analytics is definitely required, and machine learning integration. Yes, so it will machine learning is, you are training your machine. Okay, your machine learns from you. Okay, makes it learns your processes. It uncovers your patterns and it makes predictions, and automatic decision is made. Okay, so that is the machine learning. And we also have predictive maintenance. It uses data analysis techniques to predict when machinery or equipment will require maintenance, reduces downtime, and prevents costly failures before they occur. Okay, so whenever this huge amount of data is available and all the data are given to be trained, okay, only then we call it as a artificially intelligent. Okay, everybody, say for example, everybody, if they're given a tennis bat, everybody will play to some level. Yes, the ball comes, I know I have to hit it. Okay, but only a person who is trained in tennis, okay, who is trained for hours and hours in tennis or chess, for example, they only can become the grandmaster, because they have been trained for so many times, for so many patterns. So, and they know all the patterns that are available and how to play against each pattern. They know the decision. So only we call them as grandmaster, world master, all those things, because they have been trained. They have been trained to same thing. You can apply the same words there also. They can uncover the patterns, they can make predictions, and they can automatically make the decisions. Human beings. Okay. So the same thing, if I'm doing it for a machine, I call it as a machine learning. That is, it has been, we are giving it so many models, and we are training it. Okay, only then, because of that, you call it as an artificially intelligent machine. So we're looking at storage and computing, and finally we are coming to the last layer, that is the security and privacy. So what are all the vulnerabilities and threats? Yes, there are many different types of threats that are available. So devices, there are device vulnerabilities, network threats. So devices often lack robust security protocols, making them susceptible to attacks like unauthorized access, data breaches, and exploitation of software flaws. So since this is a very new technology, a very new thing in the market, Many enablers are there. Okay, in each layer we have many different vendors are available, many different products are built, and since it is also being easily built using PCBs or easily built using an Arduino kit or Raspberry or even industry based sensors are used, everybody is there. So we with the due to the different types of models that are being built and various protocols options are there, and due to this we are not able to give a unified security model. Everybody should use blockchain and this protocol and this encryption model. We can't suggest like that. But definitely if blockchain is used, we are in a one level up. And definitely cyber attacks such as hacking, phishing and man in the middle attacks can compromise a network, leading to loss of sensitive information and service disruptions. Yes, wherever data is there, wherever more number of people are involved, definitely we are definitely going to get attacks and threats are available. IoT is also prone to all these different types of threats that are available. Some of the major threats that are available in an IoT layer is, maybe we can see like man in the middle attack, or even you have DDoS, okay, distributed denial of service attack, or even as I told you on that time, it is like exhaustion attack. All these different attacks are available. Okay, different types of attacks and threats are available in an IoT. Man in the middle attack, I think you know it is a severe attack on an IoT reference architecture because it allows hackers to manipulate devices in real time. When this type of attack is conducted, a hacker intercepts requests between a sender and receiver and updates them. Meaning, so a hacker can sit in the middle and he can get the data, he can modify it and he can send it back to the receiver. So the integrity of the data has been compromised by this man in the middle attack. And we also have storage attack, wherein uh, we all know the data is stored in a cloud, huge amount of data is stored in the cloud. So definitely if the data storage is attacked, then definitely we can take off all the data from the storage. So that is also there. And we also have exploit attack. That means it is a type of attack that needs scammers to analyze a particular IoT communication model. After doing it, they find loopholes and utilize them for unauthorized access to IoT systems. So exploiting. Usually, when respect to security, we always say that we are only using a blacklisting model. Blacklisting model is, we say that do not do that, do not do this, don't try this particular software, or do not use this particular third party software, or do not click any unwanted emails. So we have lot of don'ts with respect to security. But actually, what it should be is, we have to whitelist. Whitelist in the sense, we have to make a list of software, make a list of hardware, make a list of policies which are to be whitelisted. Do's. We have to do only this. Only these particular apps are to be installed in my laptop or in my mobile or in the sensor. Only this particular protocol is to be used. So likewise, if you are having a white list of applications, white list of sensors and all the layers, we are having a white list and we are strictly adhering to the white list, then definitely we can avoid all the unnecessary man in the middle attack, insider attack, exploit attack, everything can be avoided. Okay. So whitelisting is very important when we are coming to how to deal with an attack and how to train our people to avoid attacks. Okay. So most probably attacks, whenever we take of a very big attack, whenever we talk of a very big attack, say for example in the cyber physical systems, smart grids, okay, it is a very big generator, a very big generator was attacked using a small email. Okay, so an email was being hacked, a Trojan horse, something like that, was sent to a person, and without unknowingly he clicked that. Due to that, and all the other apps were taken control of. and then the generator was triggered in the wrong time, and the generator was exploded in a power station. Okay, this happened really in a country. So this type of attacks, okay, are happening. It is possible because of the very big machines are connected to a small computer, and that computer cyber world. It is connected to the cyber world, and all the hackers are able to log into the very big devices using this cyber physical system. And so that is also another area wherein more security attacks are happening, and models have to be developed there also. Okay? And another important thing with respect to IoT is privacy concerns. Yes, we have IoT is taking all our data. Yes, even when we are walking outside, there are many cameras that are recording us, many CCTVs are there. So we do not know who are all using our data for what purpose. There are deep fake applications are there wherein our face could be morphed or used for some other purposes. Even nowadays, artificial intelligence is used to generate videos using a face that is acquired. So even if I'm not really walking outside, using my face, they can also mimic that I have been walking outside. That also could be done. So artificial intelligence, if it is used wrongly, that also can give you a lot of options. And my privacy, that is a lot of people would not. Sorry, there was a small connectivity issue. Am I audible again? Yeah. Thank you. Sorry. We were talking about security issues. So we were telling you that the data protection and then the privacy issues. We are talking about that. So I think we stopped there. So the data protection, regulatory compliance, user consent. So as I was telling you earlier days, we had this problem of uh, our own sensitive information being shared in all places. So but nowadays only that consent of getting the user, okay, we are getting an information to the user and getting his consent to sharing their personal data for ethical and legal reasons, that is being obtained. So whenever we are using new technologies or whenever we are developing new applications, definitely we have to look for all these things. What is the law that is prevailing in that particular country, and what is the privacy we have to give them? So all those things have to be monitored. So and finally, we are talking about what are all the IoT application domains. So we all know, we all have been using IoT. We have been in close collaboration with IoT projects. Many of our students are doing IoT projects, and now all the projects are integrated with AI. So earlier, it was like any project will be telling like using IoT, using IoT. Nowadays, all projects we are using the keyword using AI, using AI. So artificially intelligent. Just because the project in that particular project, if something is a decision is made and if it is able to do something on its own, we call it as an AI enabled. Okay. So it is all lies in how we are looking at it. Okay. So we have IoT applications in traffic management, public safety. Yes, IoT is used in traffic management in a way like initially only it was doing red, green lights automatically based on time. It was just switching on. But now it has developed in such a way that traffic management, what applications have come is it is able to find out how many two-wheeler riders are not using helmet and automatically implying a fine for them. By looking at their number, a fine is given to them. And even it is also able to see the traffic on the roads, and it is able to give a appropriate light. Like even if the road is empty, sometimes the green light will be always there for a particular amount of time. Only in that case, the other lanes will be not able to rest that time. So based on the traffic in that particular road, it is able to see whether we have to give a green light or a red light. So accordingly, the decision is made. So the traffic management systems have improved in such a way that automatic decision making is happening. Automatically things are being controlled. Okay. Say for example, even in the latest cars you can see all IoT things are embedded. Okay. Just like even when you are in the latest cars, if you see when you're using a reverse gear, automatically automatically the volume goes down, the song or every volume goes down automatically. We are in the alert mode. And even if seat belts are not available, always you'll be getting a beep sound, not able to cheat it. So all types of things are coming up. Okay. So wherein it is not allowing the user to do some prohibited action, and it is encouraging the user to make, so it is making a decision, and it is making things happen automatically. So traffic management is going, uh, we just put a common word called traffic management, but we have moved a long way with respect to IoT from that. And public safety, yes, all the CCTV things, and all the surveillance systems. So we think that the surveillance systems are being monitored by a human being sitting there. He monitors, there is a control room which is being taken care of, and all those things are there. But we also have public safety in such a way that the surveillance systems are also being monitored by using AI enabled software, and wherein automatically in the event of any mishap, if we see blood or if we see somebody beating somebody, so some patterns, we look for some patterns, and those patterns automatically get alerted. Automatically it alerts, it finds out from which camera that incident has happened. It sends an alert to the particular police station there. It alerts them to that particular place, so the action has been taken. So that is the difference in IoT in industry 3.0 and then in industry 5.0. Okay, so in industry 3.0 we only had CCTVs that are capturing all the pictures and showing it to us, and human beings have to be seated, they have to analyze all the data. And we thought that instead of having so many cops standing on the roads, now we have so many cameras are there, so things have been facilitated. But now the facility has gone one level more, the decisions are also made. And industrial applications, industrial IoT, we see predictive maintenance. There is as I told you already, it finds out which machines are being used, or what are all the problems that are going to occur in a particular machine by monitoring the various levels in a particular machine. And then it reduces the downtime either by automatically connecting the backup machine, and then sending this particular machine to a repair service. Okay. Process optimization, so wherever the supply chain management, wherever we want some improved efficiency, automatically how we can do it. So an asset tracking system, yes, all the things that are available within an industry, we are labeling it, we are having some tracking thing for that. So we can track where that particular asset is and how it is being used. So all the inventory management and everything is being taken care automatically by this IoT. So what else? What else in IoT? In future trends, what is going to come? So enhanced decision making. So that is the thing that is going to come. And autonomous systems. So there is no need for human intervention, and the efficiency has to be improved. Uh, Facilitates smarter decision making by analyzing massive data sets quickly and accurately, leading to more informed and efficient outcomes. So uh, we are going to see to that massive change. We are only seeing the tip of the iceberg. Definitely, this AI, IoT, and all the security enabling techniques using blockchain, of course. Uh, Blockchain is one of the latest in security. It is used to make a secure transactions. It is using only the hashing. So it has hash of the previous block will be available in the present block. So all the blocks are connected. So chain of data. So that is a good way of improving the security, and you can also see from where from the data has originated, how and all it has traveled, who are all making changes to the data. We can monitor it. Okay, so that integrating blockchain with IoT definitely creates a decentralized networks and enhance data security, privacy, all those things. Edge and fog computing, as I told you already, it reduces the latency and improves efficiency, faster response time. All these things are available. So mainly it offloads. Okay, the data computation is offloaded from the cloud server. Okay, so the bandwidth is also optimized and the computation is also optimized. Okay. Finally, I've come to a point wherein what is the government of India's policy on IoT. So from the Department of Electronics and Information Technology or the Ministry of Electronics and Information Technology, we call it as MIT or DIT, and we have a draft IoT policy. It is available on the internet. So we have a remarkable vision of generating nearly 15 billion USD within 2025, but definitely would have reached more than that. And it has been assumed that India would be have a share of 5 to 6% of global IoT industry, undertake capacity development for IoT specific skill sets for domestic and international markets, to undertake research and development for all the existing technologies to develop IoT products specific to Indian needs in all possible domains. So definitely, we have seen IoT's involvement in many places. These are the key objectives with respect to India, and there is also an IoT draft policy which gives you some uh, five-layer model, and all those things are available in the policy. If you want, you can go and visit the website. But to name a few, we have seen smart city projects are coming up everywhere. We have seen very good smart city projects in Jaipur, to name, because it has a very good facility wherein all these technologies will be used. Okay, to provide a heritage walkthrough, bicycle sharing, or even some smart parking system. All those things have been implemented in the entire city of Jaipur, and because it is being so many tourist attractions are there. So like that, and even you can see many applications. Okay, Indian Railways, they have used many IoT applications for providing a hassle-free service. So in all the places, this IoT and AI are being used. Definitely, we have to look for the improved efficiency and more and more applications which are using all these technologies. Okay, with these few words, I would like to thank you all. And if at all any questions, you can ask me. And definitely, I would like to thank all the participants. Definitely in this we're all having a regular schedule, and after that during the evening time you're all able to join with me, and we're all sharing our own insights. If you have any questions, you can definitely ask me, or definitely I'm available even later also. You can just mail me your queries or any interesting projects or any interesting internships or anything that we come across. Definitely we all can share. uh, that is what we are all looking forward. So whatever opportunities that are coming our way, definitely we both mutually we will share, and definitely we will make use of it. Thank you for all of you. Thank you for giving your time and making this session possible. Thank you. Yes, over to
Thank
Soundarya.
you, ma'am. Thank you, ma'am.
Okay.
As we come to the end of this insightful session on IoT 5.0, I would like to express my sincere gratitude to our beloved HOD, Department of Computer Networking, Dr. S. Brinda, for delivering such an engaging and thought-provoking session. Your expertise, clarity have truly deepened our understanding of this cutting-edge technology and its role in Industry 5.0. It was a privilege to learn from you today. Thank you, ma'am. Thank you for such an awesome session.
Thank you. Thank you for your kind words. Thank you.
Thank you. And a big thank you to all the participants for your active participation. Now I kindly request everyone to stay back and fill out the attendance cum feedback form, which will be shared at Zoom chat section. I repeat, I kindly request everyone to stay back and fill out the attendance cum feedback form. Dear participants, kindly everyone stay back and fill out the attendance cum feedback form, which has been shared in Zoom chat section. Now we will take a short 10 minutes break before we resume the next section.
Dear participants. Dear participants, we welcome you all for this day 2 session 4 on role of AI and IoT in smart manufacturing. We are privileged to have Dr. K. Subramaniam, Technical Manager at Samsung Technology Solutions, who has more than 14 years of industry and teaching experience, including 8 years as an assistant professor. He completed MSc in Electronics and Communication Systems in the year 2010 at Bardiyar University, Coimbatore, Tamil Nadu, and completed his PhD in VLSI design in the year 2022 at Bardiyar University, Coimbatore, Tamil Nadu. He has completed various projects reflecting his vigilant, and the projects are unmanned ground rover e-vehicle, design and development of IoT-based motor controller system for agricultural applications, IoT-based light control system, and design and development of LoRaWAN-based street light control system. Has conducted online and offline training on IoT, AAML, Raspberry Pi, and VLSI for more than 50 institutions across pan-India. We are happy to invite Dr. K. Subramaniam, Technical Manager at Samsung Technology Solutions, to present the topic on role of AI and IoT in smart manufacturing. Sir?
Yes, ma'am. Thank you, ma'am.
Thank you, sir.
Good evening to all. Myself, Dr. Subramaniam Kalimuthum, working as a technical manager at Samsung Technology Solutions. The company started in the year of recently. We have started this company at Theni as a head office. And I would like to thank the management and organized team for well organizing and we can this at FTP. I thank all, and I welcome all who are participating in this event. So we are all gathered here to know the real time and the cutting edge technology and innovative technology now ruling the world. The name of AI and IoT. Of course, the law since the last decade, we are using that technology in day-to-day life. Knowingly and unknowingly, we are using the technology. Why we are using the technology in day-to-day life? We all know, sometimes we don't know. Because the technology just we are using for the entertainment, or also to reduce our task time. Of course, maybe that kind of a thought we have. That's why we are using the smart technology, smart devices in our day-to-day life. That's why we are using the openly we are purchasing a new smartphone, new devices, and we are fitting somewhere else our devices to monitor something else. See, wherever you are going, wherever you are looking, there is some devices, the smart devices. We are calling smart device. What is the meaning of smart device? What is the little meaning of that? Anybody? No one, right? So what is the meaning of literal meaning of smart devices? It reduces our task time. No need to go for a long time, just a short time we will complete all those things, whatever we want. Right? So that is a smart device. In the smart device, what kind of a technology and technology they are integrated to develop the device, to utilize the device? Because we know that what is the IoT, that Internet of Things, right? We are right. AI, artificial intelligence, fine. But those technology, how we are using in our industrial side. We know that in earlier decades, we are used industry 1.0, 2.0, and 3.0 and 4.0. Now we are using industry 5.0. What is the difference of that? We must know that. Because if your birth is 60s, 50s, 70s, 80s, 90s, and 20s, there is a segregation. The category of industry point 1.0 to 5.0. The revolution, the manufacturing device revolution, the technology revolution comes to 5.0. The upgradation of technology in industrial side, in industrial application, smart device manufacturing devices. Why we are manufacturing the smart device? By using AI and IoT. So now we are going to elaborately discuss about the role of AI and IoT in smart manufacturing. Right. What are the roles it's going to be occupied in smart manufacturing? In the early days in the industrial side, we are used only the mechanical power to fabricate, to manufacturing the device. Whatever we want, we are used manpower and mechanical setup and electrical setup. So in the period of 1.0 and 2.0 and 3.0, we used computerized system and computerized manufacturing 3.0. And 4.0, we are using internet, completely internet. Through the internet, we are integrated, we are developed, and we are utilized the device in the manufacturing. And now we are used completely 5.0 with using AI technology, including IoT. So these are the topics we are going to discuss. The smart manufacturing, about the introduction and overview of AI and IoT, and what are the roles in smart manufacturing of AI, IoT, and case studies, and future trend, that is a recent trends in smart manufacturing, and finally conclusion. So smart manufacturing device. So how we are used AI and IoT. Right? So these are differentiation 1.0, 2.0, 3. And 4.5. So the upgradations, we are using manpower and technology and electrical power and mechanical power and computer and automation we have used, and physical automation with the internet-based development. And now we are using mass customization with AI-based technology manufacturing. That is 5.0. They occupy. So why we are calling that smart manufacturing? We know that the manpower utilizations on day by day is reducing. Right? Because we need the solutions in fraction of a second. We need the production. We have to increase the production. and the product efficiency. So these are things we have to improve, right? If you are going to use the 10 manpower for to develop the product or to manufacture the product, just use the one smart device that's enough to develop the manufacture the devices. It gives the hundred of solution, more than 10 solutions by using the one smart device. We know that in day-to-day life we are seeing that, right? So that's why we are including the cutting edge technology development. So that's why we here where it involves the integration of various technologies, including AI, IoT, and big data and automation to create a highly responsive and optimized production environment. See, AI, IoT, and big data and automation. These are the one and one is coordinated. So in this image, you can understand a machine taking one device and placing the device in place. It's nothing but the laptop. The machine picking the laptop and keeping somewhere else and checking the quality of manufacture and whether it is sealed or raw, sealed or not. It's everything. It's checking, right? And it capturing the image, whether it placed the right way, properly placed or not, and it is sealed properly or not. It collecting the data, collection of data. That is a bulk of data or bunch of data it collecting and it's sending to the storage. So that is a big data. So IoT is Internet of Things is collecting the information by using the interface with sensors and actuators and capturing the images and it processing by using the storage device or the storage data, that is big data, and finally it automated. Right? So no need anybody there to do these tasks. It automatically will be processed and give the solutions to increase the productivity. Right? And the goals of smart manufacturing. What is the goals? Our main goal is increase the efficiency and quality and cost. We have to reduce and instant decision making. Right. So these are our major goals in the manufacturing aspect. So how to improve the efficiency? First of all, we have to reduce the waste and the error. We know that in the examination pattern, we have to increase the students' efficiency. They have to study hard. They have to return well. And we have to evaluate well. That time we will understand, we will know that the students' efficiency. Right? If the students studied well, he can write the exam well. Otherwise, he can't write the examination well, right? How to study well? He have to concentrate on the reading. Then only he can read all those things and he can memorize and understand everything. So likewise here, if we want to increase the product efficiency, we have to understand the product and we have to automate and real-time process based on the material. We have to process, we have to increase and we have to streamline the operations. Of course, while go with the human manpower utilizations in the productions, so it will occur the human error. Of course, that's the nature, right? And if you go with the smart device based manufacturing unit, it will reduce the human error. At the same time, it will give the it will collect the number of data and it will process itself to give the solutions in the production unit. I mean, they are using the AI technology. They are, that is here they are using the machine learning process. And reduce the cost. Next one. So in this reduction of cost, so we are reducing the manpower utilizations and resource automations. We are doing that. And machine maintenance and energy management. So if you want to analyze the machines, so the machine number of times, how many times is it down, and how many times we are keeping ideal without protections, and how many times it occurred fault finding. So that times the manufacturing is down. So these are the things we can monitor and we can analyze the problem and we can give instant solutions. Yeah, if the machine occurred the fault means always the cost will be increased. This is our thought, but in this process, we are going to find out, we are going to analyze whether the machine going to be fault or not. Based on the routine monetization, I mean the collection of data, based on the data, we can predict whether the machine going to be make any fault or not. Simply we can analyze based on the machine learning process. That is, we can predict the machine fault. When it's going to be failure, we can easily predict. So based on that, we can reduce the machine cost. Right? And the real-time decision making. Based on the real-time data collection from IoT sensor and AI algorithms to make quick data-driven decisions. So that's why we are reducing the cost and we are improve the efficiency. So based on the collection of data only, we can predict whether the equipment or the device going to be failure or not, or we can fix the workflow, everything. And also we can predict the protections. So if the machine going to be failure means we can reduce the protection will be reduced. So if the product, if we will not wish to reduce the production means we can go with other process or other decision. Right. So these are a few things in smart manufacturing we must understand about the goals. So there are few goals of in smart manufacturing. And key points of smart manufacturing. So the automation, real-time data and data analytics, and AI algorithm-based predictions, and IoT. Right? And other than we can go with the data collections, predictive maintenance, and quality control, and process optimization. So the automations. So in this era, we are going to attach or we are going to connect the multiple IoT sensors and actuators, right? So those sensors going to monitor the device and collect the data, just like the machine temperature or room humidity and the vibration of the device or a machine. And if we are using some other application, we can monitor the pressure and the production metrics, everything we can collect by using the IoT sensors. So according to that, we can automate our process. Once in textile industry, for example, in textile industry, we are using the machines, we are monitoring the rolling cloth. Once it reached 1000 kg, it automatically cut the process and it will go for the next part of rolls. And it move to the another sections to go for the packagings and some other else. And another thing is in the real-time data analysis, real-time data collections, it will analyze itself to give the real-time solutions. So in the rolling package, whether it is 1000 kg means we have to check whether it is a quality product or not. So it will check whether the cloth is quality or not. If it is not a quality means we have to cut the cloth and we have to remove it and it will start the process again. So it will process continuously from the machine to delivery. So in the predictive maintenance, by analyzing the sensor data, the AI can predict potential machine failures before they occur and minimizing the downtime. In the quality control, so the AI can identify defects early in the production process by analyzing the data from inspection systems, and it leading to improve the product quality. Then we have to go for the process automation. So the AI can optimize production parameters based on real-time data. leading to increased efficiency and reduced waste. So how we are going to gather all the data? It comes under the IoT. So if you're not attached or connect the IoT device in the machine, we can't collect the data about the machine. While connecting the device with the machines, it should be seamless connection. Then only it can share the data in real time. Right? Now, we're going to see about what is AI, what is IoT. So we know that, so the AI is machines or systems that can perform tasks that typically require human intelligence, such as learning, reasoning, and problem solving and decision making. We know that AI is only the machine, not a human being, because the human only giving their knowledge, the human feeding their knowledge to the machine. And that machine becomes working like a man, a human. So in manufacturing, AI is used to enhance productivity, optimize the process, and improve decision making. So nowadays the AI viral in these last since January. So the DeepSeek and Alibaba AI and OpenAI and ChatGPT. Nowadays the four things are fighting themselves. Which one is best? Which one is low cost? Which one is better to utilizing, and which one is user friendly? There is a lot of things we are finding while go with these four things. So everyone we are favor with the ChatGPT and OpenAI because we are from the earlier days we are using that from last since last year 2024 onwards we are using that OpenAI and ChatGPT. And this year from January they talk about DeepSeek and what is it? Alibaba AI. So the both are China people introduced their own AI. But what is the difference of these two? If you go with the if you go and ask whatever you want in a secured question or unofficial question, if you're going to ask means both are using their some restrictions. Recently, I used the DeepSeek, my friend also. We asked one questions. So tell about the Arunachal Pradesh, the state about and the union will conclude with India or China. If you're going to ask any question about the Arunachal Pradesh means the China Deep Sea will answer. The answer, if you're going to look out, means it will favor with the China, not favor of India. The answer completely favor of China because their state is their own. They thought like that. So mostly the AI is just used for the clarifications, not for the complete solution. So we should think like that, right? Fine. So The AI, the artificial intelligence, only developed and created by the human being to reduce their task and time. Right? And to develop this AI, what are the language they are using? Means the machine learning, deep learning, and natural language processing. So the more than these languages, but the basic things is this thing. So in this AI, we are using in the manufacturing unit. So what we are going to use this AI to analyze the data, to predict the data, to for decision making. In the machine get the vibration level. So more than the vibration level occurred means we have to stop the machine, or we have to give the information, or we have to send information to the supervisor or somewhere else to replace the device or a machine. So these are the predictions we can make it by using this algorithm, AI algorithm. Right. Okay. So this AI, it can't be run alone for the manufacturing unit, because we need the coordination with IoT. So the Internet of Things. So the IoT means we know that without any human intervention, we can collect the data, we can control the device. So in this era, we are using a number of sensors and actuators. So all sensors and actuators connected through the internet with the cloud. So these sensors collect the information from the physical quantity of the physical object, and it sends the data to the cloud. And by using the cloud, we are using the AI analysis. If you want to control the device, you can give command from your cloud. So the cloud platform used for data storage and send the command from the user. So in the manufacturing industries, how they are using this IoT sensor and actuator is in this boiler plant in textile industry. So they are maintaining some boiler plant or car and manufacturing industry, or maybe automobile industry. Any industry you can take it. There have some boiler plant to maintain some certain temperature and humidity to fill the water. Right. So these are things major in their manufacturing unit. Right. So the certain level of water they have to maintain, the certain temperature they should maintain, the humidity level. There also they should maintain the room temperature also they have to maintain. Everything they have to monitor. If any one thing is abnormal, it sends the information to the user. If the abnormal is identified, it sends the command to turn off the device of the unit or a machine. If the water decreased, it automatically sends the information to the user to turn on the motor, to pump the water, to fill the tank. The boiler plant. So I'm telling you about the textile industry. They are made in the boiler plant to fabricate the quality of cloth. Even the slipper manufacturing unit, in the car manufacturing unit, they should maintain the water level to dig the pots in their water to making color. And steel industry, so everything we are monitoring autonomously and it will control autonomous. No need any human manpower. If you are using the 10 manpower, just use the 2 manpower is enough, and the rest of the 8 manpower not record is there. You can use some and it collect the information and it will process itself by using the AI algorithm. And it will give predictions. Right. So the process, how it going to be work. Right? So it data collections and data analysis and optimized decision making. So the IoT device gather the data from machines and process, providing a wealth of real-time information. And how to analyze. So the AI analyzes this data to detect patterns and make predictions and provide actionable insights. And finally, the decision making. After optimized the data, it will give some decision. By combining IoT's real-time data with AI predict capabilities, manufacturers can make smarter, faster decisions that improve efficiency and reduce the cost. And how it is working. So to collect the data in IoT domain, how it's working, we should understand that. So here we are using the 4 ecosystem, that is sensor and actuators, and hardware, IoT platform, and user. So these 2 things, sensor and actuators, we are called the inputs, and it is used for collection of inputs from the physical object and quantities, and it transmits the data to the IoT platform by using some communication protocol, that wireless communication protocol, using the hardware, by using some new cutting edge technology that may be a LoRaWAN and Wi-Fi, ZigBee, MQTT, and HTTP. These are the communication protocol we can use to transfer our data to the IoT platform. And finally, we are going to use the data visualization and data processing. So in between the IoT platform and embedded hardware and our users, we are using some kind of the technology that is edge computing and edge computing and fog computing and middleware to process our data. See, in between, so no, we want to take some decision means no need to go and discuss with our higher authority, that means maybe the principal. So in between, in middle, we have our department head. So we are going to come discuss with them, and we are gathering some solution. So without meeting directly with our principal or some other authority of a dean, we are discussing with our head to take some decision to predict some decision about the classroom management or students management. So here the fog computing, edge computing, middle were using that kind of analysis, because it not send all the data, data to the platform. It will process analysis and it give the solution to the platform. So the process of this IoT network. And evolution of AI IoT. So these are the period we are utilizing the technology Actually, in the middle of 90s and beginning of 80s, they are also since 80s also 80s we are used to this AI technology and IoT technology. But mostly we are talked about these 2018 to upcoming years. So we have started the 2008 in the machine learning and deep learning process. And 2019 we are using narrow AI technology. So it used to welcome the spam message and unwanted mails. And 2020 we are used narrow AI. It's capable of to do multitask. I mean more than one task at a time. And 2040, I mean we are working on AI, generative AI. And in future, it will come under super intelligence. There is no need any human being, just it will do all the process by using the machine. The AI machine, AI robot. Recently, we know that in some kind of a expo, the China give the human robot. It will do all those things. Whatever you want, just to command, it will do everything. In most of the company, recently I heard the news, the few of company eager to use the human robot instead of a human being, the manpower. Maybe it is in, I don't know the actual reason why the most of the IoT IT companies are closing their company and they are firing the employees. Maybe this is the reason. So the AI technologies in the AI revolutions, so it reduces the manpower utilization in their companies. In the company using 100 manpower means they're going to use only the 20%. And rest of the things they will going to reduce the AI will do everything. That's why the industry people and the wealthy people, the millionaires people investing lakh of millions of dollars, because they're collecting number of information from the human being without knowing or unknowingly. We are sharing our information to them. That's why they're collecting, they are storing their database, and they are giving some command to analyze to get the data. Right. So these are simple evaluations about the AI. In future, it will going to rule everything. And these are the key applications. I mean, in the smart manufacturing, we are using some applications using the AI IoT. So already we have discussed about things, the machine health monitoring and protection line optimization and supply chain management and quality inspection. So these four things are very much important in smart manufacturing, because without analyzing the machine health, we can't get a high protection, right? Because we can understand if the production day by day decrease means there is some problem in the machine, right? So the sensor going to be predicted, going to be analyzed by using the AI, it can predict, so the machine is fault. The machine going to be failure in future. It's going to be calculate everything. It will predict everything. So at that time we can be able to predict the machine. We can protect the machine. Right? So if the machine is good, the machine is well, it will give the quality of productions. If the machine is not good, that means the machine is going to be failure frequently, we will not get the quality of productions. Right? So what are the challenges in AI IoT integrations? The first thing is everybody know that the security concern and data privacy and technical challenges and frequent machine breakdowns and unscheduled maintenance and delays in production due to quality issues and slow inspections and inefficient energy consumption across the manufacturing floor and difficulty managing complex supply chains and production schedules in real time. So what are the devices we are going to take, we are going to use, means the first three things are a major point. The security, data privacy, and technical. We don't know the technical about the machine, how to solve it, how to resolve it, how to face it, how to solve the problem, how to maintain the machine. If we don't know, means you can't give the high productivity. So there, the efficiency also will be reduced and the cost will be increased. And it will consume the power and high. I mean, the energy consumption is high. Right? Because if we are not maintaining the machine properly, means the breakdown will be occurred continuously. We have to face it. That's why they're said unscheduled maintenance. The breakdown will be occurred often. Unexpected time, the breakdown will be occurred. So there the manufacturing, the production will be reduced. Right? So there we have to use some kind of a technology integrating the IoT device, analyzing the data, and we have to predict it, and we can analyze, we can give right solutions to maintain the machine. Right? If we face that kind of the challenges, what are the benefits we will get in? While utilizing the AI and IoT. So the downtime will be reduced, right? So while predicting the maintenance, if we analyze the data from the measurements, we can predict the machine downtime and the maintenance time also we can analyze, we can predict by using the AI. So the downtime also reduced up to 25%. So the cost lowered by 15%. And the quality will be improved. Right? So the automatic visual inspections with AI reduced product defects by 30%. And manual inspection decreased by 50%. No need to go for manual day by day. We don't need to check out. So the sensor will collect the information, the data sent to the AI. It will analysis based on the time period and how many times in the fault occurred and how many times you are maintain the device. So while maintaining the device or you are going to solve the failure things means what kind of the device you're going to use to fix the problem. So it will analyze it, so the cost will be reduced. And energy efficiency. So the IoT enabled energy management reduced the energy consumption by 20%. And the operational efficiency. So the AI-driven process optimization improved overall production efficiency and reducing production time per unit by 18%. So these are the 4 things majorly we can improve while using the AI and IoT in industrial side. So certain things in development, we are using the AI. So in the healthcare manufacturing system and smart retail manufacturing and energy management and financial side and education field and digital twin, AR, VR. So these are the applications with the AI IoT technology. So in the healthcare, to manufacturing the healthcare devices, once we are attached to the human body monitoring device, once you are connect the device in your body, it will calculate, it will measure about your body conditions, respiratory level and blood pressure level and your glucose level and your pulse, everything will be monitored. Right. So once you are attached to this kind of the IoT devices in your body, no need to go for your doctor consultation. It will give suggestions about you. I mean, it will going to be intimate about your body conditions day by day while go for outside or inside, indoor or outdoor, anywhere if you are going, it will alert you. So about your body condition. Of course. So there you can go for, it will suggest whether you need to consult the doctor or not. Or you can go for better outside, you can move outside or not. Right. And another thing is the energy management, energy device manufacturing. So in the early days, we know that the device is only the analog meter. Nowadays, they are integrated with the AI technology based energy meter. So no need any human manpower to calculate our day-to-day life EV consumption, home or industry, whatever it is, no need. So just one device is enough. So the EV meter have the wireless technology, that may be a lower or MQTT or HTTP. Nowadays, the EV meter manufactured by using the wireless communication based devices. So you can connect the device, it will send the information to the control or to the user. So how much they are consumed and what is the EV consumption bill, everything it will be calculated itself. If the tariff is upgraded or updated, it means it will automatically link with your EV energy meter. So everything is autonomous. No need any manpower to calculate your power consumption. It automatically calculates itself. Right? And education, we know that the digital twin and financial department, everywhere we are using the AI IoT. So we want to think anything means just we are the digital twin and other things. It will automatically give the solutions and it will imagine your imagination, it will come under the real field. So we know that the other one is a metaverse, digital twin here, we are augmented reality and virtual reality. Right. So in future it will comes because the AI, we not we know that the no need any classroom. Just we are the device, it will teach everything. Real classroom field. It gives the real classroom feel. It will explain everything. Just to feed all the data in this wearing device. So in this wearing device, you can it will teach everything in real time. Right? So these are the few manufacturing sector for the transportations and healthcare and manufacturing the industry for car manufacturing. So the car manufacturing is the vast industry to using the technology. So the well-being is now the EV vehicle. So current trend is the EV vehicle. Right? Electric vehicle is we can take one example. So it will give analysis. Autonomous car. And agriculture field, agriculture device manufacturing. So the drone, AI drone. Nowadays we are calling that is not only the drone, it's AI drone. So in the agriculture field, it's going to be giving the precision agriculture manufacturing. That is, it will capture the image, where is the pest, where is the leaf moisture, temperature, and where we have to flow the water, pump the water. Everything will be analysis, it will predict the system. And this is the in smart manufacturing. So in the, nowadays we are using this 5G and edge computing, digital twins, AI-driven autonomous system, and cobots and the human robots. Nowadays we are working on it, and AI we are already it's rolling the industry, and blockchain and sustainability and green manufacturing. So these are things involved in AI IoT in manufacturing. So 5G connectivity to increase the speed of computing, speed of connections for the lower latency and reliable connectivity and ultra fast. So 5G, what is the advantage of 5G means in edge computing? What is the edge computing means? It will no need to connect with a server. It will analyze itself to process the data, and it will send the final solution to the server. Right? For faster data transmission. And edge computer manufacturing for itself will take the decision and before reaching the cloud server. And digital twin and virtual simulations. So whatever you want, just to think and it will do, it will give the imaginations and your real in front of your visual. And AI autonomous systems, we know that the autonomous car, once you fixed your location, it automatically drive your car and it will analyze whether the signal or in front of and back of whatever the car will come, it will sense and it will, according to that, it will drive your car to reach your destination. And advanced robotics, cobots, the human supportive robots. So in becoming in the world, it will going to be role. So each home have their own robot to assist them. In future, definitely it will do. It will comes, and it will happens in every human being, right? And here we are. So the real time classroom feel. The human in this image, they are monitoring their human bodies. What are the parts in real life we are going to utilize, and we can understand everything. And a blockchain for supply chain transparency. So in this supply chain, we can talking. That is the AIoT, how it's working in blockchain and supply chain transparency. So we can track the goods, whether the reaching goods, locations, everything we can monitor by using this blockchain field. So the impact is to improve the security and trust between manufacturers and suppliers and customers by reducing the fraud or counterfeit risk. So we can trace it, where is the goods, because even our Flipkart or Amazon, if you want your booked means, we can trace your location where it is come. Even if you are sending any parcel or courier, it will, you can trace your based on your number. So that is, we are used this technology. And green manufacturing in agriculture field. This one video. right? So these are the ways we are using the AI IoT in smart manufacturing field. So if we want to reduce the manpower, we go with the AI IoT technology. And if you're using the manpower, it will increase your cost efficiency. But if you're using the cutting edge technology of AI IoT, it will reduce your cost efficiency and it will give you the real time solutions and the decision making. And you can monitor wherever you are, you can control your device, you can monitor your things and your factory and your everything. So if you have any doubt, you can ask me. We can go for the doubts. If you have any doubt, you can go. You can ask me. So the analysis cloud platform here, we can analyze, we can find out the solutions. Anywhere, wherever you are, you can monitor. So this is the automated driving car. So you can drive and you can. So here they are fixing their locations, right? So once they are fix their location, it drive the car autonomously, and it will check the traffic and signals, everything. So checking and itself is moving the car. Finally, it reach the destination. And this is one of things, Alexa, you know that the device, whatever you want, you can, it will do your process, it will work according to your command, right? So they it is rolling the world, wherever you are in upcoming years, within 5 years, after 5 years. So there is no manual operations. Everything is autonomous operation. Definitely it will go. Yes. So if you are asking any anonymous question or unofficial or crucial questions, it will filter your questions and it will never ask you anything about the unofficial or based on the security purpose. So we can go for questions. If you have any doubt, you can ask me. So if you in future, if you have any work or seminar internship and online sessions, anything means you can contact me. This is my contact number and my email ID. And this is my LinkedIn address, Dr. Subramanian Kalimithu. Right? So this is my company. you have any doubt, you can ask me.
Some of the participants have raised queries in the chat sections. Can you hear me? Sir, questions are
Yes,
being-
ma'am.
Questions are posted in the query section, I mean, the chat section, sir.
Okay, ma'am. Okay, I
How
will look in.
the, I just read the questions, sir. How the Tesla car, auto driving.
So you're asking about the Tesla car, right, ma'am? Auto driving, right? In the Tesla car. So we are set up with the IoT sensor and the devices and AI IoT. They're completely set up with the AI IoT based. The manufacturing car is completely AI IoT. They are used a number of thousands of sensors. They are integrated within the car. In front and right, everywhere they are integrated with IoT sensors. So while fixing the locations, so I showed the one video here. That is our Tesla car. So in this Tesla car, they are integrated the GPS tracking and GSM technology and front and back. There everywhere there are IoT sensors. Once you are feed the locations, it will drive the car autonomously. In front of they are integrated in multiple sensors, whether the signal monitoring and traffic signal, and in front of car back side car distance measuring, everything will calculate itself. They are inbuilt with the AI algorithm. So within, you may be asked one doubt, within a 10 centimeter or 15 meter, how it will going to be calculated? Because they are using AI technology, that is a deep learning process. In the deep learning process, it will give the quick solutions within a micro. We are talking about the microsecond, within the picoseconds, it will give the solution. Then that's why they use the deep learning process. So how to use AI with the IoT in agriculture? So the IoT we are using just the technology, right? I saw the one image. So in this image, we used a sensor monitoring the temperature, humidity, and water content level, NPK level, everything. And a drone, they are using the drone. In this camera, we are interfaced one camera, it captures the image. So based on the image, we can find out whether the plant is good or not, whether the plant is the wealthy or not. Everything it will be calculated itself based on the color identification. So the color will determine the whether the plant is good or not, whether it is needs something any fertility or not, whether the soil record any fertility or not. Everything it will be predicted itself by using the AI technology. So the AI works in wind turbine. So wind turbine, we know that the wind turbine used to for the energy productions. So the AI we are using for data-driven solutions and data analytic process. So per day we are producing 1 watt or 100 watt or 1,000 watt. Based on that, day by day it will be calculated. So last week what are the analysis, and last month what is the analysis? It will predict itself. So there we are using the AI algorithm. So the IoT sensors only used to collect the data, but the AI using for analysis process. For analytic process, we are using the AI algorithm. But why not in Indian car? Obviously, is the right question. But in Indian manufacturing, we are it started because recently we have made one Mahindra car, right? So in Indian car, definitely we will they will work, and we will give the solutions, because we have only hope is Tata. Definitely they will do their level based in using the autonomous car. Obviously, they are working on it, and recently they are tested their autonomous car. I think so. Definitely, they will do that. Any other questions? You can ask me. And kindly, that's my this is my LinkedIn address I already shared, and this is my feedback. Kindly give your valuable feedback. Then only I can improve whatever things I have to improve further. Right? In future, whatever help or support you need, just kindly contact me. I shared my number. This is my number. In future, definitely you can call for whatever the sessions you need, the record. I will support for your favor. Dear all, please fill your feedback form here. Any other question?
There are no more queries. Come to the end of the day 2 session 4. So we are grateful for the time and effort you have taken to share your thoughts and experiences with us. It was very interesting to hear about your real-time examples and case studies in AI and IoT integration. The slides are so fascinating and informative, which will surely open up new avenues for researchers. And I believe that we can benefit immediately from the methods you suggested in data analytics, AI, IoT for smart manufacturing. Thank you again for your contributions.
Thank you, ma'am. Thank you all. Thank you very much for this session.
Dear participants, hope you all had wonderful sessions today. Thank you all for your invaluable presence and active participation. I request all the participants to fill the feedback form. Attendance cum feedback form is now available at chat section. We request you to join tomorrow at 6 p.m. for the day 3 of FTP. Thank you, everyone.
Thank you all. Thank you.